Hello. All right. Hi, my name is Sos Sosowski, and today I would like to tell you about writing an ultra-portable game without using an engine. So especially now in the the post-Unity age, where the Unity kind of screwed everybody over, or tried to at least. I think it is imperative for both small and bigger developers to consider writing their own tech stack, to have their own technology for the games. I have a bunch of slides, so I will try to go fast. If you have any questions, it will be a bit technical at times. If you have any questions, keep them in mind, make a note of them. At the end, I will take questions. If we run out of time and get rallied out, I will be outside and try to answer anything you want to ask. So first, about me. My name is Sos Sosowski. I am mostly known for games called McPixel, McPixel 1 that came out in 2012 and McPixel 3 that came out last year. And for this game, I have made the engine that I will tell about as a case study. I also made a game called Mosh Pit Simulator that's absolutely terrifyingly bad, and don't ever play it. I made a thing called the Doom Piano. It's like a piano that plays Doom. With a bunch of friends. I am organizing a 0-hour game jam that's going to happen in a couple of weeks when the clocks go back. We make a game in 1 hour, but we start at 2 a.m., we end at 2 a.m. Actually, it's 0 hours. I also co-founded a thing called 7-Day FPS, out of which a bunch of really cool FPS games came out. One of them is super hot. You might have heard of it. I am an English teacher by trade and used to be teaching in school English, and I am a retro hardware lover. I really love like Commodore 64 and old PCs and stuff like that. And recently I also started writing MTB. That's really great. Like doing stuff that's not games after your work. That's great. Really recommend. So enough about me. I want to tell you what are we going to learn during this talk. First of all, thank you all for coming. So first I will tell you what is McPixel 3, if you don't know that. Why did I decide to make an engine from scratch? What did I consider? About McPixel engine, the engine that I used, that's what I call it. What makes McPixel engine so portable? Because that's what the talk is about making a tech that's also portable, because that's why a lot of companies and people do not try to make their own tech, because the existing tools are really portable. You just press a button and you have this game for all the consoles and stuff. And how to make your own thing portable is a thing to consider, and I did this really well. I mean, the game was ported to everything. I will tell you about that. That's why I'm sharing this. Development process and structure of McPixel engine. How is it structured for it to be portable? And pre-production steps for best scalability. When planning your own tech from scratch, you need to consider that. And some of the lessons that I've learned, how to do that without like hitting a doorstep on your way midway through. And then drawbacks, pitfalls, and advantages of the approach, and what to consider going this way. At the end of the talk, I would like all of you to be mindful. I would like you to be able to assess whether making your own engine is a good idea for you and for your product. And if you go this way, I want you to know how to take the first steps. This is what I want to tell you. So, about McPixel, I have this video. This is McPixel. It's a really simple pixelated game. That is also why I chose the engine, because it's a simple, funny game about just gags, and it's like a point-and-click adventure. And this is also why I chose this engine. It has like 100 tiny levels where you save the day. So for example, you're stuck on this running train and the trails go like off the cliff and you need to save the train, and what do? So you're stuck in this McPixel universe for 20 seconds before the train hits. So you take the fish and you hit the old guy with the fish, and then you maybe go to the bathroom and you throw the fish down the drain, and then you look and the fish is gone. The fish has been saved. Now it's time to save yourself. So you get out of the bathroom and maybe think about a way to save the day. So you jump off the window, and like a superhero you run into the front of the train, try to stop the train in the tracks, but you are not a superhero, so everybody dies. And this is McPixel. There are 100 levels like this. There are 30 mini games of different genres. There's like 6 or 7 hours of gameplay. The game is now out. You can get it, you can play it. It's right there. And it's like just goes on and on and on. It is really simple. As you can see, it is pixelated, and this is why it was so simple to work with as well. It's like budgeting the pixels. When you are a small company like me, and I made everything myself, the graphics, the music, the game. And McPixel is out now for Windows, Mac OS, Linux, iPhone and iPad, Android, Nintendo Switch, PlayStation 4, PlayStation 5, Xbox One, Xbox Series X, Xbox Series X, Raspberry Pi, Windows 95, Windows NT 3.51, MS-DOS, Haiku OS, what is this even, and FreeBSD. So it has been ported. The console, I didn't do the console port myself, an external company, my publisher, Devolver Digital. They're really great, and they got me this porting company that did the porting for consoles, so Nintendo Switch, PlayStation, and Xbox. That was not me. Everything else I did myself. And to quote the porting company, McPixel 3 was engineered and documented in a way that made it easy to feed runtime game state into platform-specific wrappers. We supported all current game consoles with much faster than what we're used to with other well-known engine. That's the keyword, much faster. Cross-platform engines. Sean Barton from 22nd Century Toys, working with them was really great, and they did port the game to all the consoles. And why it was so easy, I will tell you now. So how McPixel engine works, we'll start with that. First of all, why? Why did I decide to make my own engine against using anything else? So choices I had was obviously Unity. So Unity is great, but for the game that you just saw on the screen, this is kind of an overkill. There are a lot of features that I don't use. There's also there was this subscription cost that I would have to pay not to have the Unity logo display at the beginning of the game. So it's like, okay, maybe that's too much. And Unity is kind of made for 3D games mostly. Unreal, the same thing. That's just too much. For a simple pixel art game, I don't see a reason to use Unreal. Game Maker is much simpler, and it's kind of tailored for this kind of stuff. It was like, why do I have to buy and pay money for the Game Maker and then have this technical depth on relying on an engine that's not open source if I know how to make it my own? Then there's Monogame. So with Monogame, the problem is that it's huge. It's a huge code base of the Mono, and the .NET infrastructure is really big. And writing my own, I was like, okay, I think this is the best option for this very small thing. I can do this. And one of the concerns that I had was portability. This is the thing that I had in mind from the very beginning. I want this to be portable to anything and easy. I want this to be maintainable. I want the code to be readable. I want to send it over to the porting team, and the porting team has to look at the code and be like, all right, I can do this. And the second thing was performance. I wanted the game to run, and to run fast. I didn't want it to crawl. And these are the key priorities. So yeah, portability, maintainability, also long term. So in 10 years from now, I want to be able to go into the game and to update it and to be able to publish it still. With making my own engine in a native C code, McPixel is made in C code. It's easy because C is not going anywhere. Like half of the infrastructure in the web is made in C. And least possible dependencies. I want the code to be self-contained. I want it to be like a monolithic thing that I can just take and put onto any platform that I want. And any dependencies that I might have need to be, one, licensed properly, and two, portable, need to be right in a standardized code that will run on anything. And McPixel engine dependencies is STB image, STB Vorbis. If you are not familiar with STB, there are public domain libraries that are header only that will read images and OGG files. That's all I needed. To read PNGs and to be able to play, to load and play Vorbis file. This is embedded in the engine. It is a part of it. I do not have to pre-compile this. JSOS, that's not really a dependency. So I had like a JSON parser. All of the game is like the entire engine is like a parser for JSON scripts that display things, the actions that you see on the screen. These are all written down in JSON. And the JSON library that I had like a license issue. So I decided to just write my own. I call it JSOS. Then GIF writer is another public domain library. When you hold G while playing the game, it will record GIF as long as you're holding G. And the wrapper library. So I have SDL. So the thing is, the engine is like this monolithic thing. It's like one big block. And you just give it input, and it outputs frames. And one of the things that I need is to interact with the environment, with the operating system. So either I write that myself for every system, or use something like SDL that covers like at least 5 of these systems, because it works on all the mobiles, and it works on like Windows, Macs, and Linux. So I use SDL, but the SDL is detachable. I can take the SDL away and use something like Allegro 4.2, and then I just like rewrite this one file that sends the input and renders the output on the screen. And I have a game that runs also on Windows 95 and MS-DOS, because that's what Allegro 4 supports on top of the existing platforms. I use ncurses for a version that renders into the Linux terminal. Like you have a Linux terminal and it renders, the big pixels are just characters in the terminal. So I use that. I use Windows API to support Windows NT 3.41, and just rewriting this code, it was like 500 lines of code of a file that I had to rewrite to have this running. And I have more for different platforms as well, and for consoles, obviously. And API libraries, so stuff like, you know, you want to have achievements on Steam or I know, Google Play or on different stores. So you have to take this one another file out and just rewrite it yourself. Again, this is 500 lines of code. It's like half a day of work to do that. It's really not much, and you need to do that, like even if you use the engine, like Unity or Unreal, you need to do that anyways yourself, because that's not just given, right? So this is the engine. As I told you, you can see that it has this purple thing is the inner McPixel engine. It's a thing, I could compile that as like a DLL library. And then I give it input and clock. The clock is actually not really used because the game runs at 60 frames per second fixed. And it has like a low FPS mode that just does 2 input and update phases on one render. So it's like does 30 FPS if you want to run on like an MS-DOS. And you get back the frame data, and you render the frame data using either SDL, Allegro, writing your own library, or whatever you want. You can just print it on the printer, whatever. And this library communicates with the OS. And the idea was that this library is like detachable, and you can do whatever you want. The other thing is audio engine. So audio engine is like the part of the library. You either use the library that you're using to display, or you write your own, which is again, like a couple lines of code. I have this system that just renders, it mixes the sound, the audio, and renders it to a buffer. So all of the audio platforms has the option to like have a callback for a buffer. So you just like kind of rewrite a couple lines of code. I already was changing this like from SDL to Win API, and that wasn't a trouble, like to use the wave out. So you just use audio engine. But most of the time, you just have that. And file I/O is something that the game relies on the standard C libraries. But some of the platforms, I think Android is one of the platforms that doesn't have like the file open, because it uses the internal API. But you just write a wrapper for the file open thing, and then it just magically works. So that's all it is. So my idea was that it is self-contained. You pass input, you receive frames, as easy as that. It's like one simple block. The wrapper library can be replaced, and it's easy to prepare that for anything. And the audio is like, if it's not provided, you can revoke the buffer system that I have. It's just changing a couple lines of code. And file I/O, as I said, for Android. So next up, the details. How does the engine actually work inside? So I have game structure. This is, you can see, a part of the game structure. It has all the things. There are more things, but they didn't fit on the screen. So you have load game. You just load the file. You update the game, and you update the input. So you updating the game just does a thing internally. When updating the input, you pass over the buttons that are currently pressed. You do not have to pass like whether they were pressed this frame or not. The game does that itself. And then you call render the game, and a structure called game output is like a bitmap structure that contains the frame data. You can use it to like transfer it to a texture, or just render the pixels on the screen however you want. That's it. That's all it is. You just need to call these 4 functions. And like writing, as I said, writing like the file a wrapper for that is just a couple hundred lines of code. So the file structure is like, instead of a lot of ifdefs, I have a lot of this like main files and audio files that I just turn on and off. You can see the sizes, like look at this. Like the SDL one is big because it's for most platforms, but the other ones are like just 7 kilobytes, 11 kilobytes. It's not a lot of code that you need. And I just choose one to render. Some of them I abandoned, like the 3dfx one. There's like no McPixel. There's no McPixel for 3dfx, which is a shame, actually. So you have these different files and not really many ifdefs. There are some ifdefs by the platforms, because like some platforms, there's McPixel benchmark inside McPixel. But some of the platforms don't support like CPU ID. I need to know that if that happens. And also some of the platforms are RGB and some are BGR. So I can like wrap around, so I can just do an ifdef and then do that in code. And the build system, how does building McPixel work, like for all the platforms? So I have a lot of make files. For Windows, I have a project. I do main development of Windows on Visual Studio. It's really helpful writing C code. It has a lot of things that help. I will talk about that in a moment. And I have make files for everything else. I just like call the make files, and I have precompiled dependencies in the repository to use. So whenever I start a new platform, I take the dependencies, precompile them, and they're there forever. And then I maybe update them. And the scripts to build, so I have a build script that builds. I have a package script that takes all the files from the project, packages them in one package, because there is no system like I know deploy in Unity. I have to write that all myself. And then I have a test. I have a test suite that tests the entire game, and uploads the game to wherever I need it to go. And I have also Jenkins. You probably know about Jenkins. It's a platform that builds your game remotely. I have this old server that I bought for 500 Polish zlotys. That's like 150 euros. It has 56 gigabytes of RAM and 24 cores, and it's really slow. But I have, thanks to that, I have like 12 different VMs on that, and these VMs are different systems, and I just go to Jenkins, log in, and press button, and it builds and uploads to all the platforms. So it's really simple to set it up like that with those make files and the test suite. And also automatic testing is something that I mentioned. So I have a thing, like the entire game is interpreter for a JSON. So in JSON, everything has name, so I can call it by name. Instead of clicking in a point-and-click fashion objects on the screen, I can just call them by their names. So I have a script and a thing to interpret that script to play the game automatically, and I can test it, because for the platforms I would have to play it myself, and this way I can test it if the game is 100%able. So it's basically a script. You can see that it says like, you press the item move, you press the first door, you take the bomb, you put it on a table, and you go to the toilet, and then there's a minigame. Minigame is not playable from the script, so you just send a win message and you win. And you check if you have beaten the level, you check if you have 100%ed the level, and you check if the next level that you moved into is the level that you should be in. And the script has like all the necessary data to beat and 100% the game. And thanks to that, it works like this. Let me show you. And thanks to that, it just beats the game in fast forward. I also have like a system that does that offline without rendering to the screen for the Jenkins system. So it doesn't have to spawn a window. I can do it on a headless server that doesn't even have like a graphics library installed. Some of the animations are synchronized with the time. So the horse was dancing to the music, so then it slows down. But other than that, it rolls with like 100 frames per second and takes about 20 minutes to beat the game on a platform. And a porting example to show you how easy porting McPixel is. You know, who knows RISC-V? You know RISC-V? So RISC-V is like, you know, Raspberry Pi has ARM processor, the same processor you have in your phones. And there is ARM processors and x64, x86 processors that Intel makes and AMD for our laptops. But there's also a third player called RISC-V. It's open source, it is upcoming, it is totally new. And I'm really a big fan of that, a big proponent of that. I hope this becomes a reality, because there are no patent fees and licenses entailed in making this. So these are one of the first consumer boards for these. One is called, the left one with the blue radiators is called Nesha. Then the next one is Lychee Pi, and these two are Star5 Vision 5 and Star5 Vision 5.1. So the problem with this, I actually tried porting McPixel to this before, but to the Nesca one, but it had like a broken driver. The one, the LiCiPi, it has like, they're really short-lived, so I couldn't even install a system on it. I'm not like a super good Linux guy who can build Linux from scratch and can just use whatever I have. And the Vision 5 has the same problem, and the Vision 5 2 is only the one that now actually works. So to build McPixel, let's try to build McPixel for RISC-V. We get packages. We need build essential suite GCC to be able to build. We need library SDL2dev. You can use any of the libraries available. If not, you can use whatever you write yourself, basically. For production, I usually build it from source, but normally I would just take it from the repo and see if it works. I need Subversion to check out my version control, and I need Nano to just edit some files. And I execute a thing called build.sa, and then it works. So as I said, I tried to port McPixel 3 before to the first port on the left, Nesca, but it had a broken, botched graphics driver at that time, and I couldn't render it. So I made this thing that renders to a Linux terminal, but it is quite unplayable. So I just like, you can download the McPixel version that renders to the terminal, but it was just not a thing. I couldn't develop on a thing that has like a Pentium 2 kind of performance and memory bandwidth, and then also has to render to terminal because it was just awfully slow. I just managed to take this picture. But now I have the Star 5 Vision 5 2, and let me show you how long does it take to actually build it. So first thing I do, I don't know if you can see the letters on this, so I just go into the McPixel. You can see that it is a RISC-V board, and I call the build. I set the generic makefile, so I want to use the generic makefile. The platform is RISC-V, and I do some defines, so it is a desktop game, it is a Linux game, it is compiled with GCC, it is also, the architecture is RISC-V, and it has no CPU ID. And then I press enter. It is not the fastest computer ever, so I sped up the building process. See, it's sped up. There's a lot of warnings, but... And now it built, compiled, and then I tried to launch it, but I wrote the binary file because it's called McPixel 3. And then it just works on the first try. You can play the game. So this is what it is. If you make a game this way, with software rendering, and you have it encapsulated in this one thing, and you put it on a different platform with software rendering, every single pixel will work right off the bat the moment you put it on a new platform. You don't start with a new platform from the scratch. You just start a new platform with 100% working. This is the first time I play this game on this platform. And it just works. Everything works in this game. Yeah. So now McPixel is available on RISC-V. You can download it on h.io if you want. It's out since now. And now, ensuring engine portability. So now I want to tell you how to make your game this easy to port. So first thing is the library-like approach. We talked about that just before. You want low dependencies. We talked about that before. You want software rendering, and we will talk about that in a moment. I want to use C. You can also use C++, but I chose C, and I will tell you why, and why you shouldn't be afraid of C, and why C is not C++. And memory management is something you have to deal with yourself, and I will tell you how to use a really easy approach for that. And the premeditated bottom-up approach is something that takes care of you being able to plan the engine in a way that will work out, that you will not hit a doorstep on halfway way through and have to rework the system from the scratch. So it will get technical now. Get ready. Software rendering. Software rendering, it's kind of like if you are new, whoever wrote software rendering, can I get hands up? That's a lot of hands up. Great, because this knowledge will get you through these hard times, especially since graphics cards are really expensive. And also, if you make like pixel art games, you don't need the performance of the graphics card. And by detaching yourself from the graphics card, you are detaching yourself from the API and from the changes that you have, OpenGL, DirectX, whatever it is on like all the different platforms. So when you have software rendering, you don't need that. You don't need any of that. And the game looks the same on all the platforms. So I want to show you how software rendering is done in McPixel, how I can do it yourself, and if you've never done it, to show you that it's not that hard. So this is the blit function. You can see that the blit function is actually like the easiest thing in computing, because there is no computing. It just takes memory from one place and copies it to another place. So you can see that it just sets up some variables and runs this loop. And this loop just takes a line of the bitmap from the memory and puts it on the screen, from the memory and puts it on the screen, from the memory and puts it on the screen, until all lines are taken. There's the clip function, so if you have a bitmap that is outside of the bounds, then you need to clip it. So there are 4 sides of the bitmap and 4 sides of the destination bitmap, so you need to do just 8 ifs and that's it. And then the Sos CPI is just basically mem CPI function, just copy memory, but it also does like alpha masking, transparency. That's it. It looks like this. This renders bitmap on the screen. That's it. That's like, look at this. This is like what? 50 lines of code, here we go, software rendering. But okay, you want blending maybe? So I have blending. I have like tinting and half shadow and hard shadow and mixing. But these, I also want these to be fast. So I use these like tricks. So for example, the mix function that does like 50% blend is like, I would have like ghost effect of like half alpha translucency. So it does, I don't know if you can see the RGB mix. Let me tell you, you have this RGB data. It's like 32 bits, right? So I shift them 1 bit. I have 2 colors, the destination color and the color of the bitmap. I shift them right by 1 bit, and then I take the eldest bits of every single color and I zero them out. So I basically have half the color is like half darker, and then I have 2 half darker colors, and I add them together, and I have a perfect 50% blend. It's like super simple. It takes 3 instructions, and you can do stuff like that. You can look them up online. There are many books that you can do simple tricks like that. And you have like all the different blending. You have multiply, addition, subtraction, stuff like that. Next one is transform. So I also want rotates. And basically what I do is like I iterate the destination bitmap and pick, like sample the bitmap that I have, and see, like transform it with a matrix and see where I hit it. Basically do the same thing that you do in a shader, and you can see that it works. It's like rotates and scales properly. It doesn't look too good in low resolution if you have low resolution sprite, but it is what it is. And also you want to draw primitives. You might think, oh my God, I need to draw this diagonal line. How do I do that? But you go to Wikipedia and you're like, how to draw a line, and there's an article in Wikipedia on something called like digital differential algorithm, and this is it. And there's an example for you, and you can just like look at the example and write it yourself, and it just renders lines. It's like another 30 lines of code. And maybe you want also 3D rendering because you want to make a boomer shooter, and you can do that, and that's also not a lot of code. And you can have this like really nice, not perspective correct rendering of 3D, and all of this takes 2,500 lines of code. So that's not a lot. All of this, including the 3D stuff and the morphing stuff and the transformation. It's just that it's not a lot. It's not like when you make a game, you have like 100,000 lines of code or 50,000 lines of code or even more if you have a bigger team. So making that can ensure the portability and the maintainability and the longevity of your game, and it's just this little amount of code. So it's not hard. If you were ever afraid to write your own software rendering, don't be. And the method, let me show you what methods do I use. So first of all, I use like, I want to fake 3D in a 2D game. So I use this parallax rendering effect. That's the simplest effect that I have. But I also use the methods that were used in old games. Like, you know this thing? So this thing is rendered the same that like old Outrun games was rendered. I take like the stripes of the bitmap and just scales them and move them a bit, and they look like this 3D road when in fact nothing is really 3D on the screen. And I also have like this, raycasting. It's the same thing, but you like don't do it horizontally, but vertically. You just take the things vertically and draw them, and just scale lines of bitmap vertically according to the thing. And then you just calculate their distance using the same line algorithm that you use. It's called the digital differential algorithm. And then I have like, simple effects like underwater. Basically, take a line, move it around, render it. Simple. I have blending. I show you blending. It looks good. It works. It's a bit slower than normal blitting because you write and read from the same memory, so the cache gets invalidated a lot, but it works. And then I also have like full 3D rendering in the game. There are like objects that I just load and render. So this is what it's like. It's like all these kinds of rendering, you can have them, and it's not a lot of work, and they are performant on all the devices, even like the oldest computers and like mobile phones that I have. So step by step, let me show you how to make this kind of like old technical rendering so you can see. So this is the way that you would make, like, you just take this line. You don't do perspective correction, so the upper one is just like half of the lower one, and just take lines and put them in another place of memory and maybe stretch them a bit. That's it. This is what you get if you want like effect, like, you know, these classic Grand Theft Auto, the first game. You just take, you need the widths for every line, and then you just scale the lines of the bitmap that you have on the screen. And the next one is just like 2 times shorter, and the next one is 2 times shorter, and it looks like this. Looks 3D. This is not even 3D. It's easy. It's like not a lot of lines of code. And there's also McPixel, a benchmark mode in McPixel. So let me maybe play it and show you all the different things that you can do with the software rendering engine to make sure that you know that nothing is really impossible. So 3D rendering is something we talked about. Okay, this is really slow. Can I speed this up? Oh no. Can I move this? It did start. Okay, let us just, it takes a minute. So we have 3D rendering that I talked about. It's not perspective correct. I have later added perspective correction, but it's not really needed if you're low resolution. I have a particle system. It's really performant. You can also have particles that do the blending. So there's a lot of blending particles. I do have blending, and the blending works. You can see it here. It's, as I said, it's a bit slower because of software rendering, how the cache works in the processor. Basically, the entire game, like the performance, is constrained by how much memory bandwidth you have, because there's not much processing going on between taking the memory from one place and putting it in another place. So it's not about processor, it's about memory. Then you have this raycasting. It's not that hard to implement. There are tons of tutorials if you do have that. So you can make a boomer shooter that is actually a shooter made by boomers, not only for boomers. And then you have blending. I also have, it's not something you can see because there's no music, but the animations are all synchronized with the music. Then like complex particle systems, sure, you can have that, explosions, stuff like that. It's really easy to do. It's not much work, and that's it. So now to talk about performance. I will show you that this game does perform well, even though it's software rendered. So this is Pentium 3 from 1999, and I run this benchmark, the same that you've seen before, on this computer, and it has average of 70 frames per second. Pentium 3 800 is the minimum requirement for running McPixel at 60 FPS, but can we go lower? This is McPixel running on a Pentium MMX 233 MHz from 1997, and I am not fooling you because here's a video of it actually running. This is also an early version. I did a lot of optimization since then, so I guess the new version would run even faster. So it does run, but can we go lower? So this is a 486 DX2 with 66 MHz from 1993 or 4, and it runs McPixel. It is playable. I had to like make some bigger cuts in the game to make like a version that runs on the system, but it does work and it is playable. I beat like the levels that I made for this. And I have this thing called Hand 386 I bought from AliExpress. It has like a 40 megahertz 386 processor and 8 megabytes of RAM. And as you can see, it's not really playable with 1 FPS. Later I had to add like the decimal symbol, so it's not actually 1, it's like 0 point something FPS. But the game, you can leave the game and like after half an hour, it just loop through the levels. It does work. This is the version that I made for 486 that has like very low resource version, but it does work. This is like 35 years. Is this a 35-year-old processor? It is. It's a year younger than me. So you can make it run on anything. Like you can make the game people play it on things that they have at home. So the caveats that you have, first of all, suboptimal high definition performance. If you do want to have like high definition, think about that. So McPixel resolution is like 220 pixels by 90 pixels, and this resolution is 12 times as much. So 12 times 12, that 144 times more pixels. So that's a lot. So if you want to make HD games, maybe you can, but you would have to do some further optimization and maybe reduce the color to 16-bit color, and maybe you will be able to do some simple rendering, but you will not be able to do anti-aliasing if you are aiming for that. So, but if you make like pixel art games and boomer shooters, it's fine. That's what it is for mostly. But maybe you can fix that. I was thinking about possible fixes. So one is method optimization. This one is called rotation by 3 shares. So you know share. So it's like you have that in Photoshop. So instead of rotating, you do this like kick a sprite sideways. So it's like leaned to the side. So if you do that 3 times, you can have a rotation that's faster and looks better than the rotation that I have with the sampling. I already implemented that. It's much faster as advertised, and it's really good, but it suffers from some floating point error that you need to do the proper, like, integer and fixed point thing to have. And it's like, as you can see, that's not a lot of code. That's like another 50 lines. You can do assembly routines. That's not a lot of code, but I don't do that. I wrote that to see how it works, but I don't want that in the game because that needs to be specific for platform. But if you have like one platform that underperforms, you can think about that. And then you have single instruction, multiple data thing. So basically what you do is like, the Sos copy function. If you do like a loop inside that has like 8, is like I do 8 pixels at a time, and then actually in this thing I do it in a loop, and then the compiler would unroll the loop and use a single instruction multiple data like AVX SSE instruction to move a lot of bytes at the same time. But still, it's for high performance processors that you probably do not need to worry about. I guess mostly for mobile if you render a lot of things, but this is a thing that you can do. And also multi-threaded rendering, you can use a lot of cores. I have tried implementing that. It's not hard, but you need to know how processors works, and I don't really dive that deep, like how the cache works and how the cores interop with different caches. So I implemented that, but still wasn't able to achieve performance that is faster than the performance that I have in a single thread. Next, so we have software rendering. When we have software rendering, that will help us. Now C. I know a lot of people think that C as like C++ is C 2.0, but that's not the case. I will tell you why I use C and not C++, and why you might consider using C instead of C++, and why that might help you, because it did help me. So I chose C99 or C with new 99 extensions. So basically it's not the C89, it's 10 times younger. You can have a lot of nice things that I will show you. It is the most portable contemporary native programming language. You can think that C++ is like that, but with C you have like embedded systems as well, like Arduino and stuff like that also C compiles to. Of course, I will not port McPixel to Arduino, but it is easy. It will compile on everything, and it behaves predictably, and it has a well-established standard. You know what is a defined behavior and what is undefined behavior. If you use the defined behavior at all times, as I showed you before, you take it to like an exotic platform that is RISC-V, and the game will do exactly what you wanted it to do the same way if you follow the C* standard. And there's good compiler support for this standard, the newer standard that I use instead of the ANSI. Easy to write and read because it's like, C++ is a complicated high-level language with a lot of things. C has less things, so less things is less things to worry about, at least for me. And it's compatible with all the libraries, and there are tons of libraries out there, both C and C++. For C++, you just write a wrapper, and that's it, and you can call all the C++ functions from C. It's really easy. So why not C++? Why did I choose C? Let me tell you. So first thing, there's not really much need to go C++ for a 2D game. For 3D game, you have these, you can have vectors and the operations of vectors with operation overloading. And in 3D games, that's a lot easier because you have 3 operations and then you have 1. But in 2D games, that's 2 operations versus 1, so that's a bit less. Next, function overloading adds compilation complexity by a lot. So function level loading is something that C++ does have, even outside of classes, but it does add a lot of like type safety and complexity for the compiler and name mangling that kind of gets in the way if you do things wrong, you like make bugs and errors. So not having that does help me when I write like this simple game. STL licensing issue on exotic platform, I really wanted MS-DOS, and there's like no really good licensed STL like standard template library for MS-DOS, so that's why I avoided it. And no anonymous structs and unions. I know C++ have like a lot of things that make up for that and tools that help you build on top of the language to help you do even better things, but C has from the scratch the things that C++ doesn't, which is anonymous struct and the inline struct initialization. I will show you in a moment how that conveys into a video game kind of environment. So why not C# also? That's a question. So C# is patented, and to use that patent, Mono has an exception for patent, but only in whole. You need to use the entire standard. That's what it says in the exception. And the entirety of Mono is 200 megabytes of DLLs, and the entirety of McPixel 3 is 150 megabytes of data and everything together. So that was not an option. So now, let me show you that you shouldn't be afraid of C as a low-level language that doesn't have the thing that helps you, like things you know from C# or C++. First of all, for each, you can just do like a macro. I use macros a lot. You can think that macro debugging is hard, but it's not. I will show you that in a moment. But this is a for each thing. You just need to name things properly. So when I have things named like that, I can use the for each. That's it. And it helps because I don't have to write the same thing a lot of times. This is more complicated, like fill parse. So it takes the JSON. I need to have the like proper naming, and then I need to have the parse functions, and it goes through the JSONs, takes all the like arrays of objects and all the objects of these three types. It will parse using these parse functions. And you might not notice that it's layer set and not background, but you can use the define to change it, and it works just. So I have all the levels, have these three. There are backgrounds that you see in the parallel background. I have rooms. These are the pointed click rooms. And I have animations. These are the cutscenes that I played. These three lines just parse them automatically. You can have all of this kind of high-level stuff if you can just write it. I also have find. So you just find things by the name. You need to have the same naming, and a thing needs to have the name, like a member that's called name, and you can use the find. It just finds it. And if it doesn't, it just returns 0. That's it. You can have, this is the anonymous structures. So you can see I have the point. It's like a 2D point, but I also have it like as a tiny array for access. And if this struct inside the union was not anonymous, I would have to call it with like point.something.x, and this way I can just do point.x. And then also like in a player structure, I have the player, that the current data where the player is on the screen, and the player type, which is kind of like the costume that McPixel wears. So I can take the part of the data using the anonymous struct and just know which part of data to move to keep the same position and state of the player, but just move about his. I know in C++ that doesn't make sense because you have the like polymorphism and stuff like that in C#. But in C you don't have that, so you need to think about structures as actual data structures that you move around the memory. And this is my favorite, is the structure initialization. So this is from the beat-em up minigame in McPixel. I just put like Uncle Frank. He's like this old guy and he's dead. He's just lying there on the floor because you kicked him before you started the game. So I set the X, the Y, the dead, and on. You have that in C++, but you need to initialize every single member and in order as well. And then C, you can just like wing it. And it works. And also something that C++ doesn't have is the inline initialization that you can do inside calling as a parameter for a function. So here is me creating an animation for a thing, a kicking animation, and passing frames as an argument. The F macro is just a cast. I am just passing array as a member. I think you can do that in C#, but you definitely cannot do that in C++. This is also something that I wanted for a 2D game. You have a lot of animations, and you're calling this kind of function a lot. And also things like getting stuff from the pool. You can abstract that a lot, like without templates, but using macros. If you name things properly, it looks good. And and then it just works. And then you have drawbacks, of course. So no operator overloading, you can't add vectors and stuff like that. String operations are really, really clumsy. So like writing this JSON debugger, I was like, my mind exploded a couple of times, but it does work in the end. But they're really clumsy. This is not a modern string parsing language, and sometimes it doesn't crash. You think that C is worse than C# because it crashes a lot, and C# has the protections. But the big problem is when it doesn't, and it just corrupts its own memory and crashes in a random place, and you never know what really happened. But there are fixes for that, and there are some misconceptions. So let me go through that. That C is a subset of C++, and C++ is an improvement. That was the case. That used to be the case, but with C11, the languages have diverted. C is a language, and C++ is the language. We are at C23 now, and C++20. These are different languages made from different things by totally different people and have different principles behind them. C won't compile as C++, at least my code, and C++ won't compile as C. A lot of it does intersect because they have like a passed together, but it is not fully compatible. Macros are hard to debug. No, but because with new Visual Studio, you can just expand the macro inline. You can see, like when you have an error in the macro, you just hover over it, and you can see the expansion, and you can also click this. It will expand for you. You can debug inside. Easy. They're not hard to debug. You can also, it's easy to shoot yourself in the foot because C lets you do stuff that you probably shouldn't, but you can set some really scary warnings as errors. And if you do that a lot, it will like things that you know you might break or things that you are afraid of. You just do that in Visual Studio that I use for development, and you can have it like much easier to work with C. And also memory management is hard. As I told you about heap corruption, memory corruption, so it corrupts the wrong, like you write to a bad place in a memory to the wrong place, or you like blitz the sprites and go overboard and there's a structure after that and just write it over. You can do heap corruption detection in Visual Studio, and it will just trigger an access violation the moment you go overboard. It's so easy to track. Nowadays, in modern times, working with C is better than ever. Okay. And memory management is something like, how do you do memory management in an engine like that? Because you need to do that manually. Well, it's easy because McPixel 3 is level-based. If you make a game that's not open world, it's so easy. You just pull everything together, you allocate the memory, and just keep track on everything that you allocate, throw it into one bucket, and then you just purge it. You throw away the bucket when before you load the next level. Ta-da, done. So I have these pull functions. They just allocate the memory and put them, like, keep track of them. They need to have like some extra members, all the structures that I pull. Then I have some macros, and this is how they use them. So everything I create, I can pass a structure that it will use. If I pass the sprite to create the sprite, it will use this memory. If I don't, it will create new. If I pass a pool, it will allocate on top of a pool. If I don't pass a pool, it will allocate a dangling pointer, like for the entire game, right? And then in the end, I just call pool flush when I unload the engine, and there are no memory leaks. These differences, these are like 3 times loading the level. The differences are mostly just music, because music fades between the levels, so I don't unload it immediately. So some music instructions leave like dangling memory, so it's a bit differences. But I have like no leaks, especially on like low memory platforms. That's really great, and it's easy to do. Just put it in a bucket, throw it away. So you do this garbage collection, but you are the garbage collector, right? And the drawbacks for that, like open world games, that doesn't really work. You need to do it differently. I won't go into that. Cleaning up takes time. Like that's a lot of system calls. Maybe you could like allocate a big memory pool and then chunk it for the game. But if you don't, like especially like on mobile platforms like Android, like every single free is a system call. So it does take time. So it does like, I mean, it takes time. It takes like half a second maybe to unload the level. That's not a lot of time. And how low can you go? Well, I showed you before, that's McPixel running it with 8 megabytes memory. And keep in mind that the executable is like takes like over 1 megabyte in RAM. So this takes like 6 and a bit. Engine pre-production. And basically like with memory, as little memory you need, the little you're gonna use. So now, if you want to start making your own engine, this is like something that I would like you to consider. How to go about that, to plan the structure of the engine you are building that will fit your game. McPixel engine is not really an engine. It's just a game I built from scratch. And only McPixel game will work on that. You could probably use it to make any kind of point-and-click adventure, but it is made for that. It's made for a point-and-click McPixel game. So who is it for first? It is for 2D games, as I said. It is for pixel art games. It is for boomer shooters, stuff like that, retro-inspired games like racing strategy, and maybe simple mobile games that just don't render a lot of stuff on the screen. And now the approach, this is the approach that I taken, and this is the approach that I would like you to consider to take if writing your own engine. You make the prototype in existing technology first. So McPixel 3 was made, McPixel 1 is made in Flash, Flash is kind of dead. So McPixel 3 was first made in McPixel 1 technology. I took that, I built up on that, I made this like first levels, a demo of McPixel, and then, only then after that, I started planning the layout of the engine that I am writing from scratch. Thanks for that. I already had the data points, the kind of data, the JSON scripts that I use. I already had the levels. I had the levels. I built the levels with the features that I wanted in the final game. And I knew how much I would like it to scale. And only then I started planning making my own engine. So this is something that you should really consider. I started writing McPixel, I had to rewrite it from scratch, but then you don't have to rewrite content from scratch, only the engine. And as I shown you before, it's not really that much work. So think about that, because that in the end will save you time planning, and plus you can estimate time you need because you know how much work these things are already. And then you just rewrite it from scratch, yeah. And also a general hint that it's not connected to portability or engine, but this is something that I really came upon while working in McPixel. Like, it's really hard for programmers to say like how much a task is going to do. So what you do is you do a subset of this task. You start it before you give an estimate. Work on it on a day if it's a week task. Work at it on a week if it's a month-long task. And then you will know how much does it take. You will know the caveats immediately, and then you will be able to measure. So to measure the exact time needed to complete a development task, do a subset of said task first and compare against previous estimates. So it's a really great way not to go overboard with time measurements. And this is a bit of code from McPixel from AST. You can see that you have the backgrounds that I had before, and I have the item, and it's also like the C version was less code because I had the macros. So something like high-level language like ActionScript might be not as good as writing in C or C++. And the pitfalls that you can go into is like, you don't want to make general purpose tools. The guy who makes Godot one recently tweeted that it takes like exponentially more effort to make something from everyone than it is to make from you. Make something from you that works for you and for your team. Make tools that fits your needs. Of course, if you make like something that genre bending, it needs to be a bit more general purpose than like focused, but make things that work for you. They don't have to work for everyone. Do not overscope scalability. You know how much your game is going to scale. Stop at that. You do not have it to work on everything. Maybe you can, like, if your game explodes and you need to add more content than everything, then if your game explodes, you're gonna have all the money in the world to do that like from scratch, and that's okay. Before that, do the scale that you want to do. Do not aim too high. Do not optimize also what you don't need to. Like this software rendering, it's really fast. Modern computers are really fast. People get like faster and faster computers and phones every year, and you do not need to optimize what you really don't need to. So like, I don't have this like assembly rendering and stuff like that. I just have the simplest thing and it works for me, and that's okay. And I use that. It's still very performant. And then maybe if I rendered a lot of more things, then you can think about that. Don't think about that before time. And also component system, you know, how you have like a scene and entities have components. So that's like kind of exponentially. When you have a scene based, like a C approach, you have a scene, and on a scene you render stuff. There are no entities. That's totally C procedural approach. If you do like kind of object-oriented approach with entities, so you have a scene, and on scene you have different entities that like diverges into 100 entities on one screen. And then if you add components on top of that, you have scene and 100 entities, and all each of these entity has 10 components. So that's like 1,000 things. So it goes exponentially. If you cut down at that entity point, that's gonna help you a lot, because component systems are very complicated in a way that there are exponentially building upon the entity system. So think about that. I know that everybody is used to entity system from like, I know, Unity and all the other engines, but this is really an overkill if you are making your own language. Think about if you really need it, if you are making not a general purpose tool. And the advantages, the advantages of the engine. So the final 10% takes 10%. Okay, not really, but the initial investment pays off because you do not have to do stuff. You can do stuff inside the engine. You have written everything yourself, and you do know how things work. So, like, also there are no royalties. That's like, you know, for Unity and for all the other engines that want your money. And you have reusable code base, code that will work in decades to come. Like if you have Unity and Unity maybe stops existing, it probably won't, but or like just drops support and you can't make Unity. Like I have a lot of Flash code base and Flash is kind of dead in the water. It still works. It works on mobile, it works on, but it's not like a viable, commercially viable platform to start a new project on. So all this code is gone. And with C, all this code is always for you. It's always there. It will work on everything. Even if you use Unity, you can compile that as a plugin. And no need for workarounds. This is with what the 10% was about. So when you have not only open source, but the source that you have written, you don't need to do workarounds. Even if the most basic and down-to-earth thing is broken inside the engine, you can go and change it because not only it is open source, but also you know where it is because you have written everything yourself or your team have written. So you have access and knowledge of the code. And porting is a breeze. Not only porting the game to different platforms, but different platforms have different requirements, and these requirements are things that you need to change in the game, and you still don't need to do workarounds. You don't need to go around things. You can go right into the thing that you want to do in your game. And if you think about that beforehand, that's even better because your game and your code base will be ready for that from the start. And you have full control. This is something I pride myself. I look at the screen and every single pixel, I programmed it to appear on the screen. I did this. I not only drawn all the pixels, but I also make them happen. This is something you have full control over everything. There is nothing like, I know in Unity you have physics that you have limited control. Nothing like that. You have control over your game. And also one last thing that we'll talk about because we are running out of time is that it is environmentally friendly because if you are using the engine that exists, like Unity, to make McPixel, there are like dozens of systems that will just be dangling inside the game, running without any need. That creates impact, that drains battery, that is not environmentally friendly. If your game is written in native code and it only does what it needs to do to run the thing that you are playing, that is much better for the environment, and not only that, but also for battery. So when you make mobile games, and I know some of you do, so you can think about how much, like, how likely are people to pick, like, you know, people don't play, I think Apple announced like Grand Theft Auto or something like that for iPhones or like some high-level games. I read that somewhere, but is this really a game you play on a train where you do want your phone to have charge, or do you carry like a battery in your backpack? But when your game doesn't eat much resources, people will be more likely to pick it up in like during traveling because your game will not eat through their battery. So McPixel can be played, Steam Deck doesn't have a lot of battery, but when playing McPixel, you can play it through on a single charge because it will work for 7 hours compared to maybe like 2 hours when playing Elden Ring or stuff like that. And environment, yeah, less energy usage, good for everybody. And think about how much cumulatively energy is wasted by people playing like Unreal and Unity games that just have all these features that do not need to run there. Is this really something you want to go? And then production costs, because like when you make this game and it has lower requirements, you can buy like lower hardware. You can buy like, not really, you shouldn't buy 2011 ThinkPads to your employees, but you don't have to buy high-end graphics card. You don't have to invest as much as RAM as making like, you know, Unity or Unreal game that have these editors that take up a lot of resources. Visual Studio doesn't take much, and just having the baseline modern computer is enough. And that is it, my friends. This presentation also was 450 megabytes. That's 3 times as much as McPixel 3, which is 150 megabytes. This is the end. If you have any questions, we have, I think, time for 0 or 1 question. Do we? Hello? Okay, yes.
Okay. First of all, please remove your constant to define because you're using many RGB in the cycles. I think if you remove to cache it,
okay.
It will be faster.
Oh, just a second before you go away. If you have questions, because we will be kicked. Just a second, because we will be kicked off in a moment. I will be outside and I will keep answering questions.
Why do you do not use love2d?
Oh, because I can do this. Okay, thank you.